Today we are going to help our client, Good Lending Inc., to set up machine learning project for their microloans processing. Here's a quick reminder of the CRISPR-DM process. Good Lending Inc. is expecting a significant increase in the number of loan applications in the coming few years. They want to capitalize on this opportunity and grow their client base. Although they want to minimize their operational costs, their processing time, as well as their business risk. So in order to figure out whether this is an attractive opportunity for machine learning, we need to answer these three questions. Is there a problem? Does someone care? And can machine learning solve this? So currently, underwriting is a very manual and complex, time and resource consuming process. Also, because it's a manual process and a complex process, accuracy is a concern for Good Lending Inc. as well. Well, one way they could solve this problem is by adding more underwriters to their fleet, but that also increases their operational costs. So basically, this is why this is an attractive opportunity. And from the perspective of whether ML can solve this problem, yes, because ML is very good at capturing complex relationships between data features. And also moving from a heuristic setup to an ML-based setup is going to improve the accuracy of our predictions, thus improving the quality of our loans. What's important for ML is, do we have the data? The company has been in business for the last 10 years, and they have 30,000 loans with their approval status and repayment status in order to implement an ML solution. Now, the problem has been primarily been defined in the last slide, but let's just call out a few things that we may not have touched on. So our target user is really the underwriting analyst, to enable them to make quicker and more accurate decisions. And then the other thing that we did not touch on was the current state. So currently, each loan takes over 10 days to process, as well as the other aspect is that the loan repayment rate on approved loans is 70%. How do we define success? From our problem definition, we will define success as reducing the average processing time per loan to be less than, let's say, 10 days, because that's our current processing time. And then the other outcome that we're looking for is increasing the loan repayment of approved loans. That is, increasing the rate of loan approved loans to be greater than 70%, which is what the current state is. Now let's move on to our solution description. So first step would be to have focus groups, meet with users and review their manual heuristic process to find the logic and the relevant factors used for loan processing. For example, in our conversations, we found credit score, assets, checking, savings account balances, brokerage account balances, credit lines, age of accounts, income and employment history, and occupation as some of the relevant factors. In addition, the next step would be to perform exploratory data analysis using statistical methods and visualization to confirm the information that we found in the previous step, as well as to find any additional dependencies and relevant features. Our next step would be to select a model. We'll start with simpler models first, and we can progress based on the performance of the model to more complex models. Now, the next step, once we have selected the model, would be to design the process flow for the user to interact with the model. And remember, our user is the underwriter analyst. So the current interface for our customer, the end customer, that is the person applying for the loan, That process will remain the same. However, we will build a new UI for the underwriters to use that will interface with the model and provide the output prediction. So the idea is that we'll use the initial rounds to first fortify our assumptions and understanding, and also to refine our solutions. So here's what a proposed iterations rounds for the solution could look like. Now, what is our design going to look like? Basically, we're going to have a UI for the underwriters. The customers will interact with the ML system in the way they currently do now to make the loan applications. That will stay the same. Now, what other design decisions do we need to consider? Cloud versus edge. Since latency is acceptable currently and connectivity is assumed to be good, we are going to go with cloud. So in order to minimize latency in the workflow for the underwriter, we are going to use online predictions. We are going to use offline learning because it is easier to implement. Also, the amount of data that we are dealing with is nowhere in comparison to big data, and it's much smaller, so offline learning should be sufficient. So obviously, as with any models, we will make sure that we are monitoring for data and concept drifts in order to be able to adapt to changing environments and retrain our models periodically. What are the potential model issues that we might see in production? We could see issues with the input data and data pipeline. For example, we could have less volume of data coming in. We could have missing data, or we could have data that comes in for certain features outside of the normal ranges. So what we need to do in order to look out for that is have jobs for monitoring, using statistical distributions and data visualizations, and also perform some periodic manual audits. The other issue that can arise in production is model decay. Model decay is typically, it typically arises when there are changes in the environment or some biases getting introduced. For example, like perhaps the model starts approving more men than women, women's applications for loans. Or perhaps the model starts rejecting lower income applications more than usual. Perhaps it also starts rejecting a previously popular zip code. So we definitely need to be watching out for some of these intricate changes in relationship in and distribution of data. And one way to address this is through scheduled or triggered retraining. What other potential sources of anticipated issues are there? Basically, we need to be mindful of bias in the existing data that we use for training. For example, it's possible because humans have been processing these applications that there has been inherent bias from the perspective of gender or age. So it's important to know and understand the quality of your data that you're using to train the model. One way to address this is to, during and after the design and implementation of the model, we need to understand the predictions that it is giving us. So manual audits and reviews are necessary. And also remember that during the design, updating, and retraining of your model, if you see bias, then you factor in this bias by penalizing features that are prone to introduce this bias. So hopefully, as we implement this machine learning project for Good Lending Inc., they have a successful next few years and they grow exponentially in size. Thank you for watching. I hope you found this presentation useful and meaningful. I appreciate your time.